I recently discovered a bad neutral connection in my electrical service. In this video, I'll show all the symptoms I was seeing, how I diagnosed the problem, the actual fix, and then at the end, I'll visually explain what happened here. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. Just remember, electrical work is dangerous and should only be performed by qualified individuals. If you don't know what you're doing, don't do it. This video isn't a how-to, it's more of a how I did. There are hundreds of twists and turns this issue could have taken. You're gonna see the one path that it did take. Let's first take a look at the symptoms I was seeing. This problem wasn't all of a sudden by any means. For months I was noticing lights would flicker once in a while, but it wasn't that crazy or that frequent, so I kind of ignored it. Let's take a look at some cell phone footage I took the night before I did the fix. This is when things actually started getting pretty bad.
So I was just teaching electrical test prep class, and I started noticing my battery backup here for my teaching computer has been clicking on and off for the last few hours. So on break, I actually set up my multimeter here and plugged it into a receptacle and set it to read min and max. So this has been reading minimum and maximum for the last, I don't know, hour and a half now. And right now I've got about 112 volts there, but check out the maximum voltage. So just in the last hour and a half, the max the meter read was 134.6 and the minimum was 97.6 volts. That is a massive voltage swing. And furthermore, I noticed that this light bulb, so this light bulb, the dimmer's burned out. I should get that fixed. But this light bulb, oh, did you guys just see that? The lights just flickered and the UPS just kicked on. So there was a voltage drop, and I don't know if that was the sump pump kicking in or what was going on there, but yeah, we just had that. And look at this light bulb now. It's dim. Oh, there it just really dimmed, and I just heard the sump pump kick in. So that thing just dimmed way down. It's pretty cool. We caught it on camera there. But then we wait, and this starts to get brighter again. And that's very, very indicative of a loose neutral. So I am very convinced there is a neutral issue going on here in this house. Let's see, what is it now? 108 volts right now. I mean, it should be 120 volts right now. Again, maximum 134.6. 97.6 is the minimum. Very large voltage swing there. What is that? Almost 40 volts. Average has been 110.
Additionally, the lights in my bathroom were flickering and getting brighter or dimmer, and the UPS for my server cycled hundreds of times that day. Now let's take a look at the actual diagnostics. So the first thing I'm going to do to start really troubleshooting this is open up the panel. We need to get some measurements inside of here. I have a load monitoring system in my panel. That's what all of these extra wires are. Just remember, only qualified persons should do electrical work. It can be pretty dangerous inside of a main electrical panel. If you're not sure, leave it to the pros. So I'm going to start by taking a couple voltage measurements here. These two lugs right here are going to be the two lines coming in. So from line 1 to line 2, we should have 240 volts. And it looks like we do. That's a pretty solid connection right there. But where things start to waver is when we go from line to neutral. And this is where we start getting those voltage differences. Now there we've got exactly 120 volts. And from neutral to, let's say this is line 2 over here, we've also got 120 volts. Interesting. Oh, there it just dropped. 113. So this must be higher now. It is. Now we're up to 127 over here. That is very indicative of a loose neutral. Now we're back down to 120, so this is also probably 120. It is. And we're going to monitor this voltage, and I'm going to set the meter to read min-max. So what this is going to do is it's actually going to start logging data and figure out what the minimum voltage is and the maximum voltage is over a period of time. I'm just going to let that run for a couple minutes here. If you did not have a multimeter that has min and max on it, you're able to just watch the voltages fluctuate. The code says your voltage shouldn't deviate more than 3% on a branch circuit or 5% overall. So right now we are actually measuring right off the incoming power, which means our voltage shouldn't fluctuate more than 5% of 240 volts line to line or 120 volts from line to neutral. So it's been running for maybe 2-3 minutes now, so let's see what our values are. So our max is 128 and our minimum is 112. So we've got a 16 volt swing there in just 2-3 minutes. That very much screams to me that we've got a neutral issue. Now let's just do the same measurement from line to line. I'm gonna shut this off and reset it here. So I'm gonna shove this probe into the other line, and let's set to min max and read our live values. And I have a sneaking suspicion that we're not gonna see hardly any deviation here. All right, there the dehumidifier just kicked back on, and we saw that the voltage, it fluctuated a tiny bit, but not a whole lot. And if we go back to min max, so our max is 142 and our min is 238, which if we take a look at the math on that, so we got 240 volts times 5%. So we're actually allowed from line to line, we're actually allowed to deviate 12 volts. But from line to neutral, we're only allowed to deviate 6 volts. The rules for maximum voltage drop can be a little confusing. The code doesn't actually have an enforceable rule for voltage drop, but rather suggests in an informational note that the maximum voltage drop on a branch circuit should be no more than 3%, and from the distribution point to the final piece of utilization equipment should be no more than 5%. What this means is from the actual circuit breaker to the final load should be no more than 3%, and from the service to the load should be no more than 5%. So if the branch circuit has the full 3% voltage drop, that means the feeder could have up to 2% voltage drop. But if the branch circuit only has a 2% voltage drop, that means the feeder could actually have 3% voltage drop. And if the branch circuit only has 1% voltage drop, that means the feeder could have 4% voltage drop. Because we're just doing some rough troubleshooting here, I'm gonna pretend the branch circuit voltage drop is negligible, 0%. That means we should see a maximum of 5% voltage drop at the lugs in this panel. That is gonna translate into an absolute maximum of 6 volts line to neutral for voltage drop, and a maximum of 12 volts from line to line. Now, realistically, we should probably have no more than 2% voltage drop at these lugs in this panel. All right, let's get back to it. So this test that we just did here proved that our incoming lines are not deviating at all. We've got a solid 240 volts here. It's the reference to neutral that keeps swinging from side to side. So I've got this analog meter rigged up on line 1, and I've got this digital multimeter rigged up on line 2. Let me explain a little better real quick. What I did here was set up 2 meters side by side. The analog meter is measuring the voltage from line 1 to neutral, and the digital meter is measuring from line 2 to neutral. This isn't a necessary step in the troubleshooting process. We've already got enough information from just using 1 meter that the problem is upstream from this panel. The purpose of this setup is just to illustrate that when we see a voltage drop on one line to neutral, we're actually gonna see a voltage increase on the other line relative to neutral. Additionally, I wanted to show that a fancy meter is not necessary to see these concepts. But I do switch to 2 digital multimeters later on in the troubleshooting process. Let's set this back to min-max. We got exactly 120 volts there. We've got exactly 120 volts there right now. So right now, from line 1 to neutral is balanced with line 2 to neutral. So this voltage just dropped about 5 volts, and this voltage just raised about 5 volts. Let's wait for one of those. Oh, did you see that? That needle just moved up 5 volts, and this just dropped 5 volts. What that means is whatever on line 2 has actually created a higher load, so there's a higher amperage on line 2 now, and that's creating a voltage drop relative to neutral. On line 1, the voltage increased because of that extra weight on line 2. And now we're back down, that needle dropped back down. I'm guessing that is probably the sump pump kicking in. And right there, the dehumidifier just turned off. So I'm guessing the dehumidifier and the sump pump are on 2 different circuits. And because that just kicked off, possibly made a higher load. Oh, did you see the needle pop back up on this? And now we're back balanced again. See, now this voltage spiked and this voltage dropped. So this went up about 5 more volts and this dropped 5 volts. Our 2 lines are staying solid. We've got 240 volts between our lines, but it is that reference point to neutral that keeps moving as the load changes. So the heavier the load, the more voltage drop we get on that phase. So the heavy load gets the voltage drop, which means it tips the teeter-totter and boosts the voltage on the second line that doesn't have as much current. Before I shut this down, let's take a look at the min-max values again here. Our max value now on line 2 is 131 volts, and I've been recording this now for maybe 5 minutes. And if we take a look at the minimum value, we've got 108 volts here. So we're looking at, what is that, about 22 volt swing. We just calculated that maximum on the feeder should only be 5% of 120 volts, is 6 volts. So we should see a maximum swing here of 6 volts. We just saw a swing of 22 volts. That there alone is plenty to say we've got a neutral issue here. We can confidently say this is a neutral issue because our voltage line to line stayed pretty solid. We need to start troubleshooting where this neutral is loose. I have a sneaking suspicion it's loose outside in the disconnect. So here's the main distribution point for my property. From up top in the pole down to the meter socket, that comes from the utility company. So across the street, overhead down into the meter socket, that is all power company owned. If we troubleshoot the issue into this top part of the cabinet, we're gonna have to call the power company. I am pretty confident the problem's gonna be down here in the customer side, because I do have another shed on the property and there's also a workshop over here. In neither of those buildings am I seeing those voltage drop issues. I'm only seeing those voltage drop issues over here at the house. So that tells me the common point for the house is either at the lug in the panel, which we just eliminated as being a problem, or where it's actually fed over here. That is my assumption as to where the issue is gonna lie. So I haven't opened this up yet. I'm either expecting to see a loose connection on that neutral in here, or maybe even a corroded wire. This distribution panel is getting a little old, a little outdated. Someday I would like to do a service upgrade, but this has been working fine for now. Maybe that's going to change. We're about to find out. So again, we're coming from this panel and it goes underground all the way to the house. So the house panel is actually in the basement right about there. Now there is another meter on the house, and what that meter does is it just measures how much just my furnace and heat pump use, and I get a special rate on how much that uses. But the power company can also turn the air conditioner off if they need to on peak usage days. Otherwise, the actual incoming power is underground right about here and goes in right into the back of the panel. That second meter just measures right off of the first panel. That actually feeds that whole second panel that was next to my main panel. Over here at the electrical panel, this is the distribution point. It goes underground from here to that shed. It also comes underground here and goes to the workshop. Now again, I have not seen any voltage drop issues at either of those sheds. So to me, it's very much just isolated at the house. So let's get this distribution point opened up and see what we see in here. Wow, that's a mess. I'm guessing we've got a corrosion issue, is my guess. Or who knows what they've got going on here with these Polaris connectors either. I really haven't been in here since we bought the property quite a few years ago. Holy cow, that's a mess in there. Look at all that corrosion. No wonder we've got voltage drop issues. This is a pretty sketchy distribution panel. Those are live exposed bus bars right there. So this is pretty sketchy working in here. You see something like this, I'd definitely be looking at getting a professional to come out and take a look at it. So I do know for a fact that it is this conduit right here that actually feeds the house. At some point, the previous homeowners did a service upgrade on the house itself, and I do know that they ran a different conduit. I don't know if they did conduit all the way to the house. I hope they did, just in case we ever have to fix a neutral here. Now this is all still on. Yes, this is very sketchy. This is where being a professional with this kind of thing definitely comes into play. This right here, this wire with the yellow stripe on it, this is going to be our neutral. Right here is line 1 and right here is line 2. And they've already done some sketchy stuff with that too. It looks like line 2, they put a Polaris connector here and then jumped off onto another lug. I don't know why they would have done that. I have no idea. This is a mess in here. You know what I'm gonna do? I'm gonna grab the air compressor from the shop. So before we shut this all off, I do need to get some voltage measurements just to isolate exactly where this issue's coming from. And we're gonna do the same 2 meter test that we did in the house. I grabbed a second digital meter though, so we'll just measure it with 2 digital meters. Fortunately, this one doesn't have a strap on it. Yeah, there is major corrosion on that lug that neutral is fed from. That lug just might need to get replaced. Can I see those bolts on the back? I can. So I could replace those lugs if I had lugs. Let's see if we can actually observe this voltage issue. From here to here, 240 volts. And we do indeed have that. So from here to neutral, it's reading 40 volts because that thing is so corroded. That's why they put the Polaris connectors here. I bet it was so corroded originally when they did this service change, 15, 20 years ago, that they didn't even want to mess with the original lugs. So what they did is they spliced on, I don't want to be messing with stuff while this is energized, but they spliced these Polaris connectors on because they couldn't get the lugs off. It does look like the heads have been stripped out slightly, like somebody tried to replace them but couldn't. So I'm pretty sure the reason these 2 Polaris connectors are here is because when they originally did this service change 15, 20 years ago in the house, when they spliced on here, they didn't even want to mess with the old corroded lugs in this disconnect here, this transfer switch. This is actually a transfer switch. All right, well, let's see if we can observe this voltage drop and figure out exactly where. My guess is it's that set of lugs in the very back there. That is my guess. So if we go to line 1 here, yeah, look at that. 109 volts, 110 to neutral. And there we go, 117. So we're seeing those exact same fluctuations at this lug right here. Let's do that 2 meter setup. All right, so there okay, look at that. We see the exact split that we were seeing before. 130 volts up here, 109 volts down here. So there's about our 20, 22 volt difference that we were measuring inside the house. So we for sure have traced it back to this panel right here. And there the voltage is swapped again now. So this one's higher now and this one's the lower. I mean, they're pretty darn close. I would call that fairly well balanced. That's within tolerance. This is measuring it right off of this neutral Polaris connector right here. So this is measuring to this Polaris connector. Now what that tells me is that this neutral running underground to the house is okay. We are losing that somewhere between here and that lug in the back. So between this connector right here and that lug that is connected to, I'll get the camera in here in just a minute and show a little bit of a close-up. All right, so the way this mess works is this Polaris connector connects to that little piece of wire, which connects to that lug back there. So it's like they did like a little 4-inch jumper, hit that Polaris connector, and I almost guarantee the reason that Polaris connector there is because they did not want to touch those lugs 15 years ago when they did this. I don't know exactly when they did this service change. So we are measuring that voltage drop right here at this Polaris connector, and we're seeing that difference when whatever in the house kicks on, we see that split. I'm guessing it is that terminal right there that we're having troubles with. I mean, look at how corroded that is. That has to be it. But rather than guessing, let's actually troubleshoot it even further. So the way we would do that is now we need to go upstream from this point right here. So the way we would do that is to somehow get on this neutral bar. Yeah. I mean, look at the immediate change. So I took this top meter, and instead of going from here, we have 128 volts, but right to the actual neutral bar, we have exactly 120 volts, just like we are supposed to. So somewhere between right here and right here, we are losing that voltage. My guess is that very corroded point right there. That actually looks like the most corroded neutral point in this entire panel. So that to me is more than enough information to say that that is where the voltage drop issue in the house is coming from. Now I need to figure out how am I going to fix this. I don't have lugs that big floating around to just replace them. I could run to a supply house quick and see if anybody in town has those. Unfortunately, there's really no supply houses close to me. All right, I went an hour and a half round trip and I got 2 new lug sets here. We're gonna get them installed here. I've kind of got a plan. This is not ideal. The ideal situation here is this needs to be replaced. That corrosion's getting pretty bad. And I think the obvious reason why is it's in such close proximity here to the ground. I mean, look at, there's grass here. These are actually chives growing here. The previous owners had some landscaping here that I've obviously let go. So ideally this needs to get replaced. That'll be an interesting video here in the future. But for now, I need reliable power. So to get that, we're gonna replace those lugs, at least one set of lugs. I'll see how this first one goes, the one that needs to be replaced. And then I did buy a second one, and we'll maybe replace that other one on the side. Before I get started, we're gonna shut power off here. I'm gonna do that with the cover on. So I've already got things on the property turned off enough. So we're gonna go ahead and pull this to the middle. And because this is a transfer switch, the middle is off. Up is utility power and down is generator power. And that's what that device is over there. That is a generator inlet. I can physically see that the incoming power is disconnected. There, so now the switch is physically in the middle. Those lugs right up top there, those are still live, coming right from the meter socket. So gonna have to avoid those, but everything from here down is now completely dead. So here's my plan. This is the one that for sure needs to be replaced. This is the one that's causing the voltage drop in my house. This one looks pretty bad too, and I did buy a second lug. I mean, that middle one is bad also, but here's the problem. Those bolts that you see right there actually come around to the back side and are right back in here. I'm not even sure if you're gonna be able to see that. I'm having a hard time seeing it myself. But the problem is the pole is there. So I am not going to be able to get to that middle bolt. I'm very afraid that I'm gonna break these bolts off. There is so much corrosion. So here we can see there's a head right here. There's the middle one right there, which I'm not gonna be able to get to. And then there is another one on the other side of the pole. I am pretty confident I can replace those bolts if I need to. And I'm like 99% sure those things are gonna break when I try to take them off. So I did buy new hardware, some stainless steel hardware. Looking at how much corrosion is there, I think I'm just gonna fix what's broken. And this whole thing needs to get replaced, like I've said. So let's try to get that one off. Once we get it off, I'm hoping I'm able to clean up the bus bar. No idea what material that bus bar is. All the other bus bars in here look like copper, but man, those really look like aluminum to me with the way they're corroding. So I guess we'll find out here, but first things first, let's try to get that lug out of there. Again, everything here down is now physically disconnected. Those two lugs right there are still live, but we have physically disconnected the knife switch here, and there is no power from this point down now. Holy cow, it's coming right off. That wasn't even tight. That might have been our problem right there. I mean, it was snug, but it wasn't tight. Well, that's not even that corroded. I'm really curious what that bus bar looks like. Oh, that bus bar doesn't look bad at all. Yeah, the back of the lug still looks okay too. I'm guessing the corrosion issue is in the actual connection here. That makes me feel a lot better about this. A lot better. I see we've got a loose hot here going to the house. That's fantastic. We'll get that tightened down also. That doesn't look too corroded. I might be able to tighten that. Sweet, that bus bar actually does not look that bad at all. I think that's nickel coated copper down here, or tinned copper, or whatever you want to call it. I can't believe that came off. So now we got to get this apart. And I really doubt those set screws are going to come out. The aluminum wire going to these doesn't look too bad. We're gonna try it. I very much doubt those will come out. Yeah, there's no way. Not a chance. Nope. Nope, nope, nope. It does look like these cables are long enough though, I could cut them. Oh, this one came out. It's jammed up now. Is that enough to get it out? There it is. So this wire is the neutral for the shop, and it does not look that bad. So that is salvageable. But then we've got this wire going to the house. So I think I'm just gonna cut this wire off flush with where it goes into this lug, and then I'm gonna strip this back a little bit farther, and I'm just gonna leave the Polaris connector there because that is where the neutral for the generator inlet goes. So I grabbed a piece of Scotch-Brite here, white Scotch-Brite. I think this is the most gentle Scotch-Brite they have, and I am going to clean that bus bar up a little bit, but like I said, right behind it looked just fine. So we'll take our new lug and it should just slide right into place, and it certainly does. As corroded as this nut looks on the outside, it's still perfectly shiny on the inside. So I'm just gonna reuse this nut. Should there be a proper torque for that? Absolutely. Do I know what it is? Not a clue. Gutentite. Panel's got absolutely no information on it anymore. While I'm in here, I'm just gonna check this neutral over here, see how tight it is. Yeah, that one's still perfectly tight. So maybe it was just that nut was loose. So I'm just gonna cut this off here. I'm guessing that corrosion was starting to creep into the back side here. I mean, you can still see there's a little bit of shininess back here, but that corrosion's getting so bad. I'm guessing right here is where our voltage drop came from. I mean, we'll find out here in just a minute. And these conductors, yeah, they look just fine. I'm scraping a little bit of the old antioxidant off right now. Now, this wire right here for sure is that newer AA 8800 stuff. This, you don't have to put that antioxidant on. I am not sure how old some of these other conductors are. I'm gonna err on the side of this one. I'm pretty sure is a more modern one as well. So technically you don't have to put that grease on these conductors. These are aluminum conductors here. I am going to anyway, because, well, we obviously have a corrosion problem in here. Just gonna shmoo a little bit of that on there. Shmoo a little bit on here too. All right, we'll put the shop neutral back on. Shop neutral we'll put right there. And right now I'm just gonna snug this down with the Allen wrench, and I'll tighten it down further in just a minute. And then the neutral for the house, swing up there. Like I said, this hot looks a little loose here. It's caught really good on like 2 of the conductors, but the rest of them are loose. So we're gonna fix that while we're here as well. I'm gonna grab a different Allen wrench. The proper torque for these lugs is 275 inch-pounds. This is a foot-pound torque wrench, so it's about 23 is approximately what it is. That's kind of on the low end of what my torque wrench can do. I think it's going to be close enough. I'm also looks like going to have to use an extension here. That's going to slightly change the torque. I'm not worried about it. Probably not great to use a swivel either, but it is what it is. There it is. There we go. Might as well fix this hot while everything is de-energized. I'm just gonna loosen it up completely, reseat everything. Make sure the conductors aren't damaged. No, they're not damaged. Just dirty. Oh geez, that's loose in there too. So I don't know what size wire this actually is. It does say here it's 4/0. I don't know. Let's take this out and put it in. Yeah, this was loose too. Jeez. Let's see if we can get that right into the lug rather than using that Polaris connector. Well, that might be why. Because they couldn't get that out farther. They probably didn't want to break it. There, it's loosened up. There we go. Well, hey, we got rid of one of those silly Polaris connectors. And that should be the same 22, 23 foot-pounds. Looks like we hit that. I probably went a little over, but again, not gonna worry about it. We are still gonna leave this Polaris connector though, but considering everything else has been so loose, I am going to double check these. Oh yeah, that one was loose. That one's tight. Push those back in there. That might be fixed. So I think I'm just gonna leave this lug alone for right now. I do have a spare lug if I need it. But again, this whole thing is on the short list for getting replaced now. I don't know when that's gonna be, as soon as funds allow it. So I am gonna hop up to the side here and turn this on. So if something does arc flash, it's gonna arc flash towards you guys, and I'm gonna be off to the side. Here we go. Let's take some voltage measurements. So for right now, I'm just gonna take measurements with this top meter. So from that brand new neutral lug to our hot lug over here, we got exactly 120 volts. Remember, before we were seeing either higher than that or lower than that. And from our brand new neutral lug to, let's say, the hot going to the house, exactly 200 volts, 200 and a half, pretty much the same as the other one. So I actually feel that is already solving our problem. But let's actually do the same test that we did before. So I'll shove one probe in the neutral, and I'm gonna shove the other probe up here in the hot, one of the hots. We got 120.9, 120.1. So there is a little bit of a difference, but that's normal. Normal on this would be about 4 volt voltage drop. So I would say we are good. Now the power's been off in the house for a while, so the sump pump's no doubt kicked on, dehumidifier Air conditioners are off right now. I feel pretty good about this. Let's go inside and double check our voltages. So I just cleaned everything up outside, got that panel all buttoned up, and before I did that, I set these two meters up here in min-max mode. This is measuring the voltage from line 1 to neutral, and this one's measuring the voltage from line 2 to neutral. And again, they've been set up for min-max, so if we take a look over the last hour, the max voltage from line 1 to neutral has been 121.9 volts, and the minimum was 117.6 with an average of 120.4, and it's currently at 120.3. If we take a look at this meter, shoot, I just lost the minimum I guess now, but the max was 121 volts, and the minimum on this before I dropped the lead out of the terminal there was about 117 as well. So it's looking like everything is balanced now. We've fixed that neutral problem. There is always going to be voltage drop in any electrical system. It's just an inherent part of how wires work with electricity. We were seeing about a 30 volt spread before, and now we're only seeing about, what, a maximum of a 3 volt spread. So I would definitely say that solved the problem. I'm happy with this. I'm gonna put the panel cover back on here, and then let's go take a look at an analogy of what exactly happened here with the neutral, because I know that might not be very clear. The entire loose neutral issue can be summarized with Ohm's law, but I'm a visual learner, and I'm assuming you are as well. Here's a little demonstration that will help us understand why the lights were acting so weird and why those battery backups were clicking on and off. This visualization's a little abstract, so let me show you what's going on here. Let's imagine the left side of the beam is line 1, the right side of the beam is line 2, and the center of the beam is neutral. So we can imagine if we took a voltmeter and measured from line 1 to line 2, we'd measure 240 volts regardless of how this beam tilts. There's still going to be 240 volts from line 1 to line 2. The arrows on the end of the beam are going to show the relative voltage to neutral from that line. For example, if line 1 is pointing right in the center, that means if we were to take a voltage measurement from line 1 to neutral, whatever this arrow on this side is pointing at is how many volts we would read there. The nails on top of these beams are so I can add amperage in the form of these 1/2 inch nuts. So we can load up amperage on any one of these lines by simply adding more weight in the form of these nuts. The more weight we put on one side represents more current on that line. And finally, the rubber bands are just to keep everything balanced by default. A properly system should work like this. If both lines have an equal amount of current on them, the respective line voltages to neutral should stay roughly 120 volts to neutral. And if one line has more current on it than the other, we should still see a relative voltage to neutral on each line approximately 120 volts. But a loose or corroded neutral connection is going to act like this center pivot is loose. Now, if both lines to neutral have an equal amount of current on them, notice they balance out to 120 volts. But if a large load is added from one of the lines to neutral, such as a sump pump kicking in, or a dehumidifier turning on, or an air conditioner kicking in, notice the extra weight on that line actually causes the voltage on that heavier line to drop, whereas the line with the lighter load on it is actually going to raise in voltage. So we can think of a loose neutral as this beam that is trying to balance, but the center point is so loose it can't hold that extra weight if things are imbalanced. Furthermore, motors have a massive inrush current on startup, and what that does is it adds an even heavier weight for a fraction of a second while a sump pump is kicking in, or an air conditioner, or a dehumidifier. So when those motors kick on, there's a huge inrush current on that line, and that further imbalances the voltage. That's why having that multimeter with the min-max value was able to show us those absolute minimum voltages and those absolute maximum voltages. Because when those motors start up, that inrush current is very fast. And then things actually bounce back to what their running current is. So just watching that meter change voltages, we're going to be missing those massive increases when that motor kicks in. And that's where we got that massive spread. So when this happens, any lights that are on this line are gonna see a lower voltage, which are gonna make them appear dimmer. Any lights that were on this line are gonna see a higher voltage and they're gonna seem brighter. Let's clarify a few things real quick. Voltage drop is totally normal and naturally occurs, even in a perfectly operating electrical system. This demonstration was just a rough analogy. If we wanted to visualize real world voltage drop as well, the normal stuff, this beam itself should actually have a tiny bit of flex to it as well. That would take into account the actual normal voltage drop out on a branch circuit or on the actual conductors that go out to loads. In this case, we were only focusing on the voltage drop caused by that loose center point, that neutral connection. When we measured the line-to-line voltage, we did not observe any crazy voltage swings. That told us the incoming line voltage was stable from line to line. That's why we were only visualizing it here as a solid beam. When we measured either line to neutral, that's where we started to see those voltage fluctuations. That implied the problem was at the common point between those two measurements. And if we were to measure line 1 to neutral and line 2 to neutral, the common measurement point is that neutral connection. That's what narrowed us down to the neutral being the problem here. There absolutely can be voltage issues on one particular line. Say, for example, one of the line lugs was loose. We could see those voltage drops on just one line, but because we were seeing it on both lines to neutral, but not from line to line, that triangulated us to that neutral being the issue. If you found this interesting, like, comments, and subscriptions are more than appreciated. Special thanks to all the Patreons making this possible. Thanks for watching. We'll see you on the next one. Bye.